7.4 is translations and vectors. Okay, we've kind of already talked about translations, right? Okay, a translation is just a what? It's like a glide. It's like a shift, okay? We're just taking something and we're shifting it over, up, down, or over in the opposite direction. So left, right, up, down. Okay, those are your types of translations. Now, with translations, again, we've already kind of talked about it, so I'm not going to go real in depth. Okay, if this is AB and I shift it that way, I now have B prime, A prime. That would be a translation, correct? Okay. Do I need to define it more than that? Okay, I'm not going to go real deep into the definition here. The first theorem you have is your translation theorem. Okay. Again, you don't need to write that down probably. It says a translation is an isometry. Okay, so you should be good there. Okay, the first theorem that we do need to write down, though, okay, we are going to call the double reflection theorem. Now, we already did one that was called the double reflection theorem, correct? Okay, that's okay. This one's going to be a little bit different, but it still has the same idea. You're reflecting how many times? Twice, doing double reflection. Okay, this tells us if lines K and M are parallel. Okay, now our previous double reflection theorem, the lines had to intersect. Okay, this time they're parallel. If lines K and M are parallel, then a reflection in K followed by a reflection in M is actually a translation. Okay. So what this tells us is that if I have two lines K and M and they're parallel, and then I have segment AB, okay, if I reflect that one time over K, then I get what? A prime, B prime. Okay. And then I reflect it again over M, which gives me what? Good. A double prime, B double prime. Okay, if I do that, then it's actually the same thing as doing what? Just translating it, just shifting it that way. And you guys can kind of see that. That looks pretty much the same as this, right? Okay, so really, instead of doing a double reflection, I just took this and I shifted it over. Okay. Yep, they most definitely are. Thank you. Okay. Now, there's more information to this than just that little bit. Okay, they also tell us that if the distance here is d, okay, so that's the distance, what? In between my parallel lines. If the distance between my parallel lines is d, then the distance that I translated from b to b double prime is 2d. Which would be the same as from A to A double prime, right? Okay. And does that make sense, everybody? Very similar to our last theorem, right? Okay, except this time instead of the angle doubling, your distance doubles. Remember, this only works when your lines are parallel. Okay, now, there is more to this still. Okay, the next stuff I draw on my diagram, I wouldn't draw if I were you. Okay, it'll just kind of make a mess of it. But you can write a few things. Okay, there's one other thing that we need to, or a couple other things we need to know. The first thing is that A double prime, that segment, okay, so this segment right here is parallel to B double prime. Okay, which should be fairly obvious to you guys, right? Okay, if I'm just taking the shape and I'm shifting it, okay, those two lines are going to be parallel to each other. Okay. The other thing, I don't want that. That we need to know is that those same segments, A double prime and B double prime, are perpendicular to K and M. And perpendicular means what? They intersect to form a right angle. Good. Okay. Any questions on that theorem? Now, just like on your theorem from the other day, that's going to be very obvious when you should use that. Okay, so what I want you to do, everybody flip to their assignment portion of this lesson. Tell me what number starts using that. What problem number do we start on using that? 20. Pretty obvious, right? Because the diagram looks exactly like that. Is there any other ones that you can see in that lesson where you're going to use this theorem? Not really, right? Okay, 20 through 24 is the only group of problems where you're going to use this. And it's very obvious because your diagram looks exactly like that does, right? Okay, so be aware of that. It's going to be very obvious when you use this theorem. It's not like they're going to try to trick you. Okay, you'll know. You'll know when you have to use this. All right, let's go ahead and flip our page here. Okay, we need to talk about some things in the coordinate plane. Okay, that's basically what the rest of today's stuff is going to be about, is things in the coordinate plane. Okay, the first things we need to talk about is just making or doing a translation in the coordinate plane. Okay, so let's say I have this segment here. Okay, so I have 5, -1, and I have 1. Actually, that's not the one I want, sorry. I want, let's do this one, -7, 3, and -4, -2. Let's do something like that. Hey, remember, if you want graph paper to do your notes on, use that manila colored stuff in the middle of that bottom shelf, please. Okay, so I take that. This is A. This is B. Okay, and then I shift that over here. Let's put it here. So I have 2, 0, which is going to be A prime. And then here I have B prime at 5, -5. Okay, so I took this segment and I shifted it over, and I shifted it down, right? Okay. We have to describe this somehow. Okay, we got to find a way to describe this. The first way that we're going to learn to describe this is called coordinate notation. Okay. In coordinate notation, we have our original xy, which in this case, for this one would be -7, 3, and for this one would be -4, 2. Okay, but you just leave it as xy. But I'm taking those 2 points and I'm translating it. Okay, the question is how far and in what direction. Okay, so first comes your x. How far did I move my x? How far did I go? Left or right, correct? X is left and right. How far, Carly? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So I went from -7 to +2, which is 9. Which direction? To the right. On my x-axis, is the right positive or negative? Positive. So I have x plus 9. Okay, I took my x, I added 9. My y went where? Where did I go on my y-axis? I went down 1, 2, 3, right? So this is going to be y minus 3. Okay, and I could apply these. If I just went here and I did -4 plus 9, what do I get? Positive 5. If I do -2 minus 3, I get -5. Okay, so if I just plug my x and y in, I would get my new coordinates, right? Okay. That one's called coordinate notation. Okay, that's going to be a pretty common one for us to use. They might not always give it to you on a graph. Okay, that's another place you got to be careful. They might not give it to you on a graph. They might just tell you, hey, find the image of 2, 5, and then they give you this. They tell you your translation is x minus 1, y plus 3. What do you do with these? I plug them in. I want to take, first of all, if I'm finding the image, that must mean this is the what? The pre-image. Good. Okay, so if this is the pre-image and I want to find the image, then I need to do this translation, right? So I need to take my 2 and I need to subtract 1. And I get? And I need to take my 5 and I need to add 3 and I get? That would be your new coordinate point after a translation of left 1 and up 3. Okay, now I want to do one more here, because there is one part of this that's going to be confusing on your assignment. It's going to say find the pre-image of -6, 4, or something like that. If they want you to find the pre-image, what does that mean this is? So that means that's the ending point, right? So how do I find the pre-image if I know this is how we got to here? Good. I have to do the opposite, don't I? Okay, so you have to be very careful when you're doing your assignment, because the word image and pre-image make this problem very different, correct? Okay, so Ryan, here I do -6. Do what now? Since I'm going the opposite direction? Do I still subtract 1? I add 1, so what do I get? -6 plus 1 is -5. And then, Carly, I do 4 minus 3, which is 1. Okay, you just have to be very careful and understand, did they give you the image or did they give you the pre-image? Okay, which one are they asking for? Be very careful and be aware of that. What was this notation called? Coordinate notation. One of those things you probably didn't get down if you didn't take very good notes. You can kind of think of it like that. Yeah. I'm not going to tell you that because I think that might confuse some people, but if that works for you, then you're good with that. Okay? Now the next thing, and really the last thing we really need to talk about, is vectors. Okay? First of all, this is a vector over here. Okay? This is a vector. Okay? It looks like a ray, correct? Okay, but it's a vector. It could also be called a ray. It's a vector mostly just because I'm telling you it's a vector. We'll go deeper into this in a second. But the main thing I want here is, what is the name of this vector? X, Y. Okay, just like in a ray, it's not YX because this is the starting point, this is the ending point, correct? Okay, so make sure we name these properly. Don't name these backwards. Okay, a vector space there. Okay, the definition of a vector is a quantity that has both direction and magnitude. What's magnitude mean? Size. It's just how big it is. Okay, your vector has both direction and magnitude. Now, just like I talked about over there, if I have this vector AB, this is the starting point, right? What was that called? The initial point. And then this was called the terminal point. Okay? Beginning, end, correct? Now, with a vector, it'll typically be in a coordinate plane for you. Okay, so let's say I have this vector at -1, -2, and then it ends at -4, 5. Okay, with a vector, we don't typically use coordinate notation. Okay, we use what we call component form. Or also, sometimes you'll hear me call it vector notation. Okay. In component form, you can still tell which direction you're going and how far. Okay. How much does my x change here to get to here? 3, but negative, right? Because it's left. Okay, so I have negative 3, comma, and my y changes 7. Positive, because I went up, right? Okay. The difference in component form is you have these funny brackets around it. Okay, those brackets are going to tell you that you have a vector. If you don't have those brackets, you don't have a vector. Okay, what happens if you do this? That's a coordinate point. Is that the same thing as this? No, that point right there is not the same thing as this, is it? Okay, you have to be very careful. Okay, every year, I have at least 2 or 3 students, because there's like 5 or 6 questions on your test that tell you to put something in component form. At least 2 or 3 students put parentheses around it. Is that wrong? Yes. Okay, even if you have these numbers right, the problem is completely wrong. Because is this anywhere close to this? No, visually, just looking at this, yeah, right? But it's not when you put it on a graph. Okay, you have to have these brackets, otherwise you're not really even close to the answer. Okay, so make sure we understand component form does not have parentheses, it has brackets. Does coordinate form have parentheses? Yes. All right. That's not what I wanted to do. All right. Let's take a look here real quick. Last thing here. Example 3. Part A. Seth, name that vector for me. Okay, part A, that is vector J, K. Royal, name the initial point and the terminal point. Okay, Vincent, what is the component form of that? 3, 4. With brackets, right? Okay. Matthias, part B. That vector is what? Mn, meaning M is the terminal point, or excuse me, M is the initial point, N is the terminal point, right? Give me the vector notation of that. That one's a little tricky. Good, 0, 4. And then the last one, Austin, name that vector. TS. Hey, Austin, go ahead and give me the vector notation for that, please. Careful. Which one, does one of those, does that go up or down? Down, so that should be a negative 3, right? It's a 3, isn't it? Okay. Okay, make sure if you go left, it's going to be negative, and if you go down, it's going to be negative. Now, should I be able to take both of those and write it in coordinate notation? Or excuse me, all 3 of those. Yeah, this should be x plus 3, y plus 4. This one should be x plus 0, or just x, and then y plus 4. And this one is x plus 3, y minus 3. Okay. So can you still write a vector in coordinate notation? Yeah, you can. Okay, I want you to be careful. In your homework, you're going to have to move entire shapes. Make sure if you start like at the top left of a rectangle and you translate it, make sure you end at the top left. Okay, go to the corresponding vertices, please. Okay, that's the only way you'll get the proper answer is if you go to the corresponding vertices. Alright, for this assignment, I'll get it up here in a second, you are going to need one sheet of graph paper and then also a smaller sheet to go along with that. Okay, so you'll need one sheet from the right side and one sheet from the left side. I'll get you guys your quizzes back on Monday.